Ladies and gentlemen, hello and welcome to Hot Technologies of 2016. Today's topic, application running slowly, time to get precise. And don't we all know too well what problems that can happen when stuff is running slowly? This is Rebecca Joswick. I am filling in for Eric, who is kind of doing a whole new role here today. So yes, this year is hot. And when it comes to technology, like I said, the one thing you really don't want is a slow running anything, any part of your system. And just to kind of use a consumer example, I mean, if you have a restaurant, it doesn't matter how great the food is. If the service is slow, you're probably not going to end up going back. Now, it's easy kind of in a restaurant to figure out why something is running slowly. Maybe the kitchen is short-staffed, or there was a malfunction with some equipment, or maybe the wait staff is a little lazy. And it's kind of easy to identify and get that fixed. But when you think about a data center, it's a completely different story. It could be a network issue, a bad query that's jamming things up, application performance, or a faulty cable can even cause some problems. And troubleshooting with that type of complexity can be difficult at best. So that's kind of what we're going to be talking about today. And we've got, as I said, Eric Kavanagh chiming in as analyst today, and we've got Dez Blanchfield, our data scientist, and we have Bill Ellis from IDERA, who's going to talk about his company's solution that helps with application performance management. And with that, I'm going to pass the ball over to Eric. Eric, the floor is yours.
All righty, sounds good, folks. And that was a great analogy, actually, because you spoke to the difficulties or ease with which troubleshooting can be accomplished, and you get right down to it. Performance issues always result from some kind of problem that's in the network. I mean, it could be as simple as old hardware, for example, but the bottom line is any situation like that calls for troubleshooting. So that's what I'm going to talk about today, and let's go ahead and jump on the slides here. So here comes troubleshooting. It's fun for people who like it. That's the cool thing. If you find someone who likes to do troubleshooting, hold on to that person. Get them some tools to get the job done. Because it's really good stuff if you can find someone who gets to the bottom of something and gets stuff done. But the bottom line is that troubleshooting is problematic, and it always has been, and it always will be. And if you start talking about troubleshooting, what you're really getting at is root cause analysis. What is causing the problem? Well, if you just sit back and think for a second about even the mainframe days, there were all kinds of issues that could occur. And back then, you had to have people who really knew their stuff because there weren't very good tools to do troubleshooting. So you really had to know your command prompt. We'll talk about that in a second. And I actually forgot to put in one of my favorite slides. I'll look for it while we're on the show today, maybe during Dez's presentation. But I wanted to show, for anyone who hasn't seen it, one of the funniest British TV shows ever is called The IT Crowd. And in terms of troubleshooting, the Irishman, who is one of 2 IT people in the whole company, always says the same thing when any call begins. Have you tried turning it off and on again? So do try turning it off and on again. You'd be amazed how often that simple thing can solve some problems. So those of you who have done troubleshooting at home, maybe with your parents or friends, probably not with your kids because they seem to know what to do, turn it off and on again. But regardless, troubleshooting is not easy. It's not ever going to be easy, but we're going to talk today about some of the things you can do to make it easier. So the command prompt, yes, indeed, I'm old enough to remember the early days of computing when all you had was the command prompt. You do dir, enter. That's what I would do, see the directory of files. I feel positive that I actually got some command done, right? Dez, of course, our data scientist, he knows how to use the command prompt. And if you can use the command prompt, that is great stuff because most of us mere mortals use some kind of a GUI, a graphic user interface, but there's always some disconnect between the GUI and the command line underneath. And just to give you a random example, if you want to know how much code some of the basic programs out there bake into documents these days, go into the latest version of Microsoft Word, type hello world, then do save as HTML, and then open up that resulting document in a text editor, and you'll probably see pages and pages of tags. That's called code bloat. And code bloat is not really good for troubleshooting, just to be blunt. So, of course, client-server came along, and that was great stuff. In a way, we're kind of going back in that direction, but just think about the complexity that came into the situation. Now, where is the problem? Is it on the client? Is it on the server? Is it in the network? Where is it? Besides which, just think about viruses, and when a virus would get into one computer on the network, what can happen? It can go anywhere. Data breaches are crazy these days. They cause performance problems. We've had Russian hackers we can identify by the IP address. We're pretty sure they're Russian, or they're very clever Ukrainians, or Polish, or even Americans using proxies. But we've had hackers come into our little old site, Inside Analysis, over the years and cause all kinds of issues. Stuff just stops working. You can't get stuff done. Stuff that used to work doesn't work. How do you know? How do you know what it is? WordPress, just as another example here, is a very complex environment. It's very difficult to get into the weeds and really understand how things are taking place in WordPress, especially if you get a whole bunch of plugins. Stuff can go crazy pretty quickly. But I'm kind of getting ahead of myself. So I threw in here, always be wary of the upgrade. Upgrades always scare the daylights out of me, certainly operating systems. I remember the days when Microsoft would actually suggest that, yes, you can upgrade your operating system from this version to that version. Well, I tried a few times, and that never, ever worked. So just remember, the larger, the more complex your environment is, the more unwieldy the situation is going to become. And there's virtualization. Think about what VMware did to IT. It revolutionized IT, but it also created this layer of abstraction. So if you've got a layer of abstraction at that foundational level, that's a whole new ballgame. It's a whole new ball of wax, and you really have to reassess what you're doing, and all the old tools had to change. And now, of course, it's the cloud, right? For the customers, the cloud is great because it's very simple. Usually the interface is pretty straightforward, but of course you don't really have a lot of control over the cloud. But for the folks who are behind the scenes, there's a whole lot of stuff that they need to know and understand these days. The environment has become much, much more complex. And certainly with e-commerce, and you think about all the money that trades hands these days, that's why you will not find me in favor of a cashless society anytime soon. So the bottom line here is that the situation is getting more problematic by the day. And keeping performance optimal is always going to involve some element of troubleshooting. I don't care what anyone tells you. There's no perfect tool, there's no silver bullet, and there never will be, because in another interesting perspective here, we're still learning to speak silicon. We're still learning to understand how even networking works at the nitty-gritty level. If you look at systems management software, it's getting pretty good these days, but still, you're looking at lines going up and down, and you're looking at representations of reality. It's going to take a person who knows what's going on to stitch together the clues that you can ferret out through your tools to be able to understand what's working and what isn't, and it's a lot of trial and error, just to be blunt. So with that, I'm going to hand it over to Dez Blanchfield, and then we'll hear from Bill Ellis of IDERA, who's going to put us to shame with his knowledge. With that, Dez, take it away.
Hey, thanks, Eric. In fact, you led nicely into my little segue. So my title, Performance Art, I think is extremely apt in the context of what we're chatting about today, because in many ways, when we think about performance art, we think about dancing and music and other creative things, and frankly, more often than not, if we're solving problems in very large-scale IT environments and business systems, there is indeed an element of art, and often black art. Because the situation, in my experience in some 25+ years, is that the modern app stacks are very rapidly increasing in complexity at a rate that we have never seen before. And we're frankly struggling to keep up. And there are organizations such as Uber, for example, and the Pokemon Go development team. I mean, they're experiencing growth and complexity, increase in complexity at rates that are just astronomical. There aren't even books written about it because we hadn't conceived that level of growth. So my view is that the core definition of an application stack is morphed exponentially, and I'm going to explain why I think that's the case, and then lead into the challenge at hand that our good friends at IDERA appear to have a solution to solve. Very briefly, we all know these, but just to recap them, in the early days, we had what I call application architecture version 1.0. It was a server computer, in this case a mainframe with a bunch of terminals attached. It was relatively easy to diagnose issues. If you weren't seeing things on the terminal, you could track down the cable between the terminal and the server computer, and it was either a serial cable or a connector or some issue. If it was not related to the terminal and you were seeing things on the screen, it was pretty easy to work out that the stuff that was causing the issues was in the machine itself. and you could slowly diagnose where in the stack that was from the hardware all the way up to the software layer and the user interface. In what I call version 1.1, we made it a little bit more complex. We put devices in the middle so we could put more terminals in place, and they were some sort of communications device, and often they were muxes or multiplexes, and they would either run over a dedicated line or a dial-up line, and so you had a mainframe at a distant location. It could be interstate or internationally, and some device connected over an SNA link or some sort of WAN connectivity, and those terminals still operate the same way, but you had a little bit more complexity because you had to figure out whether the issue was between the terminals and the comms device or from the comms device and the mainframe. But the stack stayed relatively similar in the mainframe. Version 1.2, a little bit more complex again because now we added more devices, we added printers and other things, and we clustered these things. And we had a thing called a front-end processor that would handle all the issues of the devices locally, printers and terminals and so forth, with a mainframe at the distant end. A little bit more complexity, but again, the consistent theme of the mainframe were the apps running locally. So problem solving stayed fairly similar inside the application stack. And we had people with skills around sorting out issues with terminals and printers and cluster controllers. But then we complicated things and we built networks, and all of a sudden the same sort of architecture introduced a network layer. So all of a sudden we had a network switch, and workstations that were a lot more complex. And this version of the architecture, we often had graphical user interface apps at the workstation. So not only did we have a server running the app stack, but we also had another stack of applications running locally, and of course the same basic model of devices connecting to a server. Then we took a quantum leap to the more recent model of what I call 2.1, which is where we took that app stack and we made it a lot more complex, a lot harder to diagnose, and we introduced a lot more devices at the front end, so web browsers and PCs and mobile devices and so forth. And here the application stack then started to dive a little bit deeper into integration into the operating system and hypervising underneath. So in this image here on the right-hand side, we've got the whole stack, including network infrastructure, storage, servers, virtual machines, the operating system, and then the traditional three tiers of database and middleware applications, et cetera, in the front end. Diagnosing application issues and performance issues in this model just became a lot harder. There were so many more moving parts, and trying to drill down through that stack was just, became a nightmare. And you had to develop additional skill sets in the organization to deal with that. It wasn't just your application team anymore. All of a sudden now you had infrastructure people, you had database specialists purely just working on database, nothing else, as opposed to a systems programmer who knew their way around databases. Now we've got a scenario where IT departments have to deal with a significantly broader complexity of as a service, and this is where the world just exploded, and our problem-solving challenges became, it went from being a nightmare to just something that's almost intolerable in some ways, and this came about as a result of the scale we're trying to deliver services at. So version 3 of what I consider the application stack has introduced this as a service model, where a traditional model on the left-hand side, the enterprise IT stack, where everything had to be managed at our end as the consumer and the supplier services, from application security, databases, operating system, virtualization, servers, storage, networking, and data centers. We had to manage it all, but we had access to it all. And so we could scale out our capability and technical skill sets, and we could drill right down through that stack and we could find things. But as the infrastructure service and platform service and a software as a service model came along, all of a sudden our access to the back-end infrastructure, our access to the platforms and the tools that we delivered services from were kind of taken away from us. So as we started to consume infrastructure as a service, we only really had the top 4 pieces, from the operating system, the database, the security environment, application stack, and above available to us. Everything under that was black magic. And that gets even more interesting when you move to platform as a service, because all of a sudden you're just managing the application stack. When you get to software as a service, and a traditional model of that is webmail or internet banking, all you have is access to a web browser. So trying to diagnose what's behind that is intolerable and difficult. And I've broken this up into time zones, into slots of time or eras of time, if you like, or generations, in that from left to right, we've gone from sort of pre-2000s in the traditional stack, where we had access to the entire environment and we could drill down through that, but over time it became more and more complex, to early 2000s, to mid-2000s, to late 2000s, to current day, where we've gone from infrastructure as a service, platform as a service, software as a service, and now we're essentially referring to as business as a service. And the complexity has increased dramatically. There are so many more moving parts, but the availability of skills gets harder and harder and more difficult to avail ourselves of. Finding people with the right skill sets, with the right access to the right tools to get and dive into this stack and find out where is something running slow. Is it my laptop or my desktop? Is it my phone? Is it my tablet? Is it my connectivity over 3 and 4G, or my dedicated link with ADSL or ISDN or whatever it might be, or even dial-up, although that's less and less the case these days? Is it the web server end? Is it something inside the web server? Is it the app server? Is it something around the memory and disk and CPU and network performance inside the application server? Is the database running in there? And you can imagine now, you draw this picture very quickly of the complexity that starts to expand, kind of like a Big Bang image of this ever-increasing bubble that we're trying to get our arms around and have the skills to dive into, and the knowledge and wherewithal to dissect and pull apart. And we're very much now at the era where the human beings can't cope with the physical scale, even if you've got the capability to pull the database environment apart and pull that database apart and dive into the detail within that database. The number of databases you have to manage now are growing rapidly. Everything is powered by our database. Very few applications these days are not powered by a database. And the types of databases are growing rapidly as well. It's not just the traditional SQL database anymore. Sometimes it's SQL, sometimes it's NoSQL, sometimes it's a graph database, sometimes it's a document database. And there are all these different types of functions these different types of databases have. And as a result, each of them have different performance challenges and different performance criteria. Logging databases and document databases perform very, very differently and perform a different function to a traditional ACID-compliant, ANSI 92 compliant SQL database, and the types of things that can be stored in there. And so we're now at a point in my mind where, and I think Eric alluded to this, that human beings are struggling to keep up with the complexity of what we're building and the speed at which we're building. And we're now at the point where the only way for us to manage this infrastructure and the only way to monitor and to delve into some of the issues that we're facing are with tools, and the right types of tools, and invariably the right generation of tools that actually understand the back-end infrastructure. It isn't okay anymore just to throw an SQL monitor or an SQL query tool that something start to pull apart a query and see what makes it work. We actually need a tool that understands the formation of queries and the appropriate way to form queries and the appropriate way for queries to talk to the infrastructure of the back end and how they're performing as they do that, and to look at the timing of those interactions and the order in which they take place. And that's a much more complex challenge, and that leads me to my roundup point, and that is that as the complexities of the app stacks we're developing increase, the performance tools and the tools that we use to manage those necessarily need to become increasingly smarter, and not just more capable of looking at more things, but also a lot smarter at how they delve into what's running at the back end and what they can discover about it, and potentially even some sort of analytics being performed over that to understand the interactions and the performance that's being delivered and why it's performing slow or faster. And with that, I'm going to pass to our dear friend from IDERA, Bill Ellis, and we hear what he has to say today about how they've solved this issue. Bill, over to you.
All right. So my name is Bill Ellis, and thank you very much. We're going to talk about my application is running slowly, time to get precise. So let's see what precise an IDERA product can do and how it can help you. So a lot of times you only find out that there's been a performance problem because an end user has called you. And that's really a big problem in itself. That everybody in IT, nobody knew until the phone rang. Now the next big problem is, how do we help this particular individual? And it's really not a trivial problem. So there's one takeaway from this that's above and beyond this slide. It's above and beyond the others, and I want you to see if you can get it, what it is. But as we had mentioned, an application relies on a lot of different technologies. The application stack is tall and growing. And many people access an application via a browser. And surprisingly, there's more and more processing that's happening in the browser with scripting, et cetera. And then, of course, you have the network, the web server, the business logic code, and the database.
One thing I want you to consider is that every significant business transaction interacts with the database, whether it's time card reporting, an inventory lookup, a purchase order. The database is being updated. And so the database becomes really the foundation of performance. And the database, of course, in turn relies on the downstream on storage. So each of these technologies is tightly coupled, and being able to see what's happening, being able to know what's going on, being able to measure is critical. Now, one thing that we find is that many of our customers have a tool, and they have a tool for each technology, but what they don't have is context. And context is basically the ability to connect the dots between every tier in the application stack. And this is actually a relatively simple. We used to have a limitation of 12 tiers. We basically changed it. We have unlimited tiers, and we support mixed environments. So we can basically get extremely complicated with a precise solution. Now, at a high level, this is how we solve the problem, and it's focusing on the transaction. The end-user transaction from click to disk tells us which ones are running slow, which ones are consuming resources, but the key is this: we are able to pick up the end-user ID, their location, and not only the entire transaction time, but how much time is spent at each individual step. Time is the currency of performance, and it also shows us where resources are being consumed. We don't know up front where the problem is going to be, so we need to have the adequate metrics and analytics at each of the tiers to be able to diagnose where the problem might be. Now, in today's presentation, I'm going to focus in this area. I want you to rest assured that we basically provide the same level of visibility at every tier in the application stack. And the crucial thing is this is going to tell us who, what, where, and then this part is going to tell us why. And it's really the why. It's absolutely critical to solving problems, not just knowing about them. Now, the other thing that came out very clearly in the presentation was that it's impossible to do this. You need automation. And automation means that you have alerting. You have something that tells you, hopefully before the end user community, so you have ongoing trend, build up deviation from trend alerting, and then we also offer line in the sand. You're actually breaching an SLA. Now, we offer a lot of information. Not everybody needs to consume the complete buffet. Some people just want to have a light snack. This is salad. And so with that, we offer a portal where you can bubble up information that just meets a particular user or a particular community's information needs about performance. So the application is running slowly. It's time to get precise. We're really going to focus on 4 things. One is the location, pinpointing the end user, once again, that context that connects the dots. And the third-party research shows that nearly 90% of the application issues are in the database. And so it's really kind of a travesty that the majority of performance solutions might tell you what SQL statement, but they don't tell you why that SQL statement is running slowly. And so the why is really the crucial thing. And Precise is excellent at showing why for every tier, and in particular the database. And just to share a little bit about our support matrix with you is we support SQL Server, Sybase, DB2, and Oracle. The look and feel of the solution is very similar. So that if you're looking at multiple applications with slightly different architectures, the information I'm sharing here, kind of the look and feel, the approach is the same no matter what the underlying technologies in use happen to be. Precise is web-enabled, so we come in, we authenticate to Precise, and with that, we go in, and the first thing we might want to look at is performance by location. And so you can actually see here the different locations where people are accessing the executions. You can see if somebody abandoned a page before it fully rendered or if there's errors. Now, one thing with these applications is the network or the distance from the application server does make a difference. So it's very easy to kind of see here, that there is some level of network. I can see when people became busy. And then another interesting thing, he talked about how there's processing within the browser. I actually noticed that some of the different browser types provide a better environment for fast processing. And so knowing if people are accessing by Chrome or IE or whatever it happens to be, you'll actually can find very often that one browser type and version is actually superior to another. Now, sometimes you have publicly facing, you don't control the browser. Sometimes your applications are internally facing where you can recommend a particular browser type to your end user community. And so these are the types of deep dive visibility and analytics that Precise is able to provide. Now, we get into looking at an application. I'm not sure if you guys can see my pointer, but I wanted to describe to you the top graph. The y-axis shows average response time. The x-axis is time across the day. And there's actually a stacked bar graph. And that stacked bar graph, the total shows you what the performance is. And then it shows a tiering of how much time is spent in each individual step or each individual tier of the application. From the client through the web server, the green is the Java. In this case, we're using Tuxedo, and down into the database. Now, the lower half of the screen shows the different web menus that are being accessed. And we have them sorted. So a little green arrow is pointing down, so it's in descending order, and it bubbles up to the top, the web menus that are the slowest. We actually show the execution count, the response time of each individual technology, and then there's actually a bar graph for each of those web menus. And so we start to get an idea of what's going on. Now, remember, we started this off with an end user who had called. But how do I find that end user? I come in here, I open up a menu that allows me to filter on a particular user. So I set that user to AlexNet, click OK, and then we're focused on just the activity from AlexNet. Now, what this does is it allows IT and IT management to be directly responsive to an end user. And you can see here that they were looking at content management. They had 6 executions with a response time of a little over 3 seconds. Well, 3 seconds is pretty good. It's not terrible, but maybe it's slower. What I can do with this is I can slice and dice this information a bunch of different ways. I could say, well, is this transaction slow for everybody? Is it slower today for Alex than it had been yesterday? Is it slow for every user within a particular location? And what that does is it allows me to kind of slice and dice and get an idea of what's happening, how universal the problem is. And it's very important to be able to identify the end user because it's not just about the software and the infrastructure, it's also about how the end users are exercising the application. Oftentimes, you might have a new employee or somebody who has a new job function, and they're not familiar with certain SAP screens or certain PeopleSoft panels. And they need a little pointer. Maybe they're leaving fields blank or putting in wildcards, and they're forcing a large result set to be returned from the database. By having an user ID, you can actually call them before they call you. The other thing that we find is that once the user community is aware that IT knows what they're doing, is a lot of times they become better behaved. And a lot of problems that had, a lot of things that had been issues just kind of evaporate because people just operate a little bit more carefully. They use the system with greater care. So that end user identification is essential. And it's essential for IT to be able to help a particular end user. Now, what we've done here is we've gone to the Flow tab. You can see that in the top left-hand corner. And we focused in on one particular component of the web menu. And on the right-hand side is an analysis of that particular transaction. And so at the top is actually the browser. And then the U kind of just get you familiar with a little bit of the icons within the GUI. The U is for the web server, so we can see the entry point, and then the J, of course, is Java, and then the T is for tuxedo, and then naturally the blue is SQL. Well, that hash value is basically identifies a particular SQL statement. So consider what this does. We've identified a user to a transaction to the underlying application code, including the individual SQL statements. Now, when I look at those individual SQL statements, I can see that of the total response time, each of them is responsible for about 6%. And when I add up the top 4 SQL statements, we're talking about a quarter of the transaction time. Now, often the database is the easiest to manipulate. It's the easiest to get inexpensive, much superior performance. And I need to go a little bit deeper to find out what's going on. And what Precise is able to do is actually reveal the individual SQL statement. And I can almost guarantee you that just about every single shop that they're on the line has some sort of database tool. And what the database tool does by just looking at one technology in isolation is you look at and focus on the health of that technology. And a lot of times people will look at like a top 10 list. Now, this SQL statement is pretty fast. It's not going to be on the top 10 list, but it is the SQL statement that this transaction relies upon. And so what I can do, back to that word context, is now I can bring this to the DBA's attention, but in the context of the individual SQL statement. Now that person can open up Precise in context of the individual SQL statement, and Precise captures the actual execution plan, the user execution time. This is important stuff to the DBA. We'll actually show, you can see that 50% of the time is spent waiting on storage. 50% of the time is using the CPU. So I start to get ideas of where the time is being spent, how I might whittle that time down. And the idea is to give people options, because different responses have different costs and risk associated. Ideally, we're after the low risk, low cost solution to a problem. Now, that SQL statement is tracked by a hash value, and there's in the left-hand kind of middle of the screen, there's a little tune button. And what that's going to do is it's going to take me into the SQL tab, and this SQL tab is kind of a pre-built workbench. And what this does is it allows me to really analyze specifically what's impacting the SQL statement, starting out with the execution plan. The execution plan is chosen by the optimizer when the statement is parsed. It basically, back to the food analogy, it's the recipe that's followed to resolve the SQL statement. And some recipes are more complicated than others. And so we provide findings, and it will actually show here that, hey, a lot of the time is doing sequential I/O on a particular index. And so now, going back to that option thing, well, this index, has that index been defragmented recently? What's the health of it? What table space does it live in? Is the table space segregated from the table it references? And so it starts giving you all sorts of ideas on how you might go about resolve the problem. Now, obviously, rebuilding an index is a lot lower risk, a lot easier than maybe moving an index from one table space to another table space. So what we're wanting to do is kind of build up options so that we can deploy the lowest cost, lowest risk option to solve the problem. Precise can also do things like capture bind variables that are passed to a SQL statement. Obviously, the variables that are passed are going to control the size of the result set, and will control how long that SQL statement takes to execute, and how much data has to be passed and processed by the application through the Java, through .NET, into the web server, passed across the network, and finally rendered in the end-user browser. So what happens in the database directly impacts that browser time. And so it's really crucial to have this level of visibility so we can know exactly what's going on and give the DBA the most options so that they can choose which one makes the most sense given a particular situation. Now, these are some of the quotes, and this happens to be from a PeopleSoft shop that has global deployment. Precise supports PeopleSoft and SAP, Siebel, Oracle E-Business Suite, homegrown Java and .NET applications. We support heterogeneous, so if you make web service calls to multiple JVMs, from Java to .NET, back to Java, we can track all of that. It could be on-prem, it could be in the cloud. The crucial thing is that things need to be instrumented. And so just a couple of quotes from one of our customers. Before Precise, our DBAs were using OEM. That's a database-only tool. And they basically said, hey, the instance looked great, but they couldn't help tell or address a problem with a particular transaction. Precise provided the visibility to do that. And so having that information about the SQL statements was critical about giving the DBAs the visibility to really squeeze performance out of the database. And so that was really nice. So kind of above and beyond some of the tools that you might be looking at. And then IT management really loved the fact that Precise was able to translate a complex URL into a panel name. And that way, if an end user calls up and says, hey, I'm having trouble with this, you can isolate and see, well, what do they execute? Who is that user? What are they executing? What kind of performance? They're actually measuring the rendering time in the end user's browser. So it's a true measure of the end user experience. And so also having that user ID is absolutely essential to helping a particular person who calls. So how does Precise do this? And so we'd like to kind of share our architecture. Precise should live in its own server, it can live in a VM, it can live in the cloud. On the front end, Precise is web-enabled, whether you're using dashboards, the alerting interface, or the expert GUI. On the data collection side, we can actually do agent lists for several different technologies. Oftentimes, though, we will require an agent, and there's pluses and minuses to having an agent. A big plus is this, is that data that's collected can be pre-processed before it's sent across your LAN. And so that basically can minimize the total impact of the monitoring solution on the target environment. Now, just consider as an alternative, if you have quote-unquote agent lists, there's still a data collector, it's just a matter of where it lives, and it's making calls and passing raw data about the target application across your LAN, and it's actually that can be pretty expensive. And so by pre-processing, we can actually minimize the footprint. We'll be able to monitor both physical and virtual. And one thing I wanted to say about virtual technology is the VROPS really focuses on utilization. What Precise focuses on is contention. When is the VMware technology actually minimizing resources to your guest VM? And so it becomes really easy. If you're only looking at the OS metrics within a guest VM, you have only part of the picture. So being able to automatically detect and alert on contention is really essential. Precise can monitor up to 500 instances, so very large deployments, you'll typically have multiple Precise servers. And for a global deployment, typically there'll be a Precise server in each data center. Incidentally, for the very largest deployments, you can actually federate these together, so you can actually look corporate-wide about what's going on and be able to offer reporting, etc. Now, as I had mentioned, we have a lot of technical analytics. Not everybody needs to go into the expert GUI, so we offer a customizable dashboard. And each of these portlets or widgets, they're all optional, and so, somebody might want to just know, hey, have we hit an alert on any tier within our environment? How are the end users doing from a performance perspective? Or maybe you might have a question about the infrastructure, getting into maybe even tuxedo performance, or even load balancing. Kind of interesting here in this load balancing, I'm looking at the portlet in the middle on the left-hand side. You can see that the number of executions is very similar between each of the web servers, but the response time is very different on the top one. We could actually drill in and find out exactly the reason why the response time on that web server was much slower than the other ones. So one thing about load balancing is it's very important. And load balancing policies, not every load balancing policy is appropriate for every application. So it's actually really helpful to validate your load balancing policy. We're actually seeing with some applications like the new PeopleSoft Fluid GUI, where actually some web servers will go offline. And so that's something that's really critical. If you're deploying PeopleSoft Fluid GUI, please contact us. We can provide you with a lot of insight and a lot of knowledge about what other customers have faced with it. Each of these portlets can be pretty detailed, like this, the middle right, with the blue and green, actually shows the sawtooth pattern. It kind of shows that your garbage collection within the WebLogic tier is running the way you expect it to run. And so each of these portlets can be highly focused, or it can be very high level. And the reason that that's important, or could be important, is a lot of times it's not good enough to just have this information within IT. Sometimes you have to share the information with application owners, and sometimes with senior management, depending upon what's going on. So I wanted to share with you a couple of stories, kind of success in the data center. And these are database focused, and I have other stories that are middle tier focused. But for today, I really want to focus on the database tier. So let's take a look at screen freezes. Now, what happened here was that this particular shop had a business SLA that if an order is received by 3 p.m., the order ships that day. And so the warehouse is extremely busy during that time frame, and they were getting screen freezes that was very, very frustrating. And so the supervisor actually, this is a smaller company, the supervisor actually walked into IT and, of course, goes up to the DBA and says, what is going on? And so what we did is we were able to show exactly what was going on. Now, this is J.D. Edwards in multi-tier application. This is the sales order screen. You can get an idea of what the business was. It's basically a just-in-time inventory. And so you're basically looking at warehouse applications. And, you're basically shipping to a number of different customer sites, different stores. And what we did is we opened up Precise. Now, in this case, before we looked at Oracle, here we're looking at SQL Server. And now the top half shows us a stacked bar graph of where the SQL statements spend their time while executing. Every wait state is accounted for on the y-axis. The x-axis is, of course, across time. And you can see that the stacked bar graph changes from time slice to time slice depending upon what's executing and how it uses the system. Now, in this particular case, we focused on the third SQL statement from the top. Its text is select from PS prod. And you can see in that column that we captured the actual execution plan. And you can see here the number of executions, the fact that that particular SQL statement was responsible for 9.77% of the resource consumption during this time frame that we're looking at. And that's an important point, the time frame. Precise keeps a rolling history. And so I can basically dial in and find out what happened at any particular point in time or over time, so I'm able to do trending. Now, this SQL statement, you see the stacked bar graph there? It's dark blue. That says we're using all CPU. So let's go ahead and focus by clicking this tune button on that particular SQL statement. What we do is we take it into that workshop. Pre-built workshop is designed to say, well, what's the DBA going to know about this particular SQL statement? And you can see on the right-hand side, there's a tab called History that had been selected. And what I'd like you to do now is kind of shift over to the left-hand side where it says changes versus average or duration average duration. And each of those bars represents a day. So you can see on Wednesday, Thursday, Friday, the execution time was, I'm going to round to 0.2. The y-axis shows 0.4 seconds, so 0.2. So very few screen freezes. Operations are going great, meeting the business SLA. Unfortunately, on February 27th, the execution plan changed, and that caused an immediate change in how much in the execution time. So all of a sudden, the execution time is going up 4x, maybe 5x, and things are running really poorly. Now, Precise, in its repository, actually journals all of the changes that might impact behavior. And you can see here that we've actually captured access plan changes. There's the one in the middle says table volume change. And so the tables are growing. And we're right on the cusp when the SQL statement is parsed, the optimizer chooses one execution plan or a different execution plan. Now, luckily, on this week here on Monday, it flip-flopped. So it been a good time. Unfortunately, it flip-flops again. And you know what? The end users start anticipating screen freezes, and they start resubmitting that screen, and they push the execution count up and up and up. We have a huge amount of detail, but to solve this problem and avoid it in the future, we need one additional piece of information. And that's shown to me under the comparison of those execution plans. On March 5th, when it was fast and efficient, on the left-hand side, it shows the execution plan. When it was slow and inefficient on March 12th, you can see it's doing a filter join. The filter join just forces a lot more CPU consumption, it's doing a lot more work. The outcome is identical, it's just doing a lot more work. It's like you go and get your supplies one ingredient at a time rather than go to the pantry and get all of the ingredients at once. And so there's just kind of more efficient ways to do this. Now, knowing this, the DBA was able to use query plan to avoid the slow execution plan and lock in fast, high performance. Now, the next kind of war story was reports are late. I think a lot of people can identify with this scenario. You might have ad hoc reporting. You might use a tool like Envision. You might have some third-party reporting tool. And what happens is the tool develops the SQL. And oftentimes the SQL isn't really coded that well. And this could also apply to a situation where you have some third-party application, right, where the SQL wasn't in-house written. And so as a DBA, I don't control the SQL. What am I going to do about it? Well, Precise provides something that I'm not aware of any other database tool providing, and that is an object view combined with recommendations and modeling. And so what we can do is actually turn visibility on its head. Rather than just look at activity, let's investigate, well, what object is heaviest on the system. And in the kind of the lower part of the screen, you can see the order line table, and you can see the in MS SQL column, and it's probably, the order line table is probably 10 times busier than any other table in the system. I did want you to also notice in the top half, the space allocation is growing, and you can also look at the specs on the server, what version of software we're running. Precise will actually track changes to the parameter settings. Once again, cause and effect. Now, focusing on the order line table, what I can do with my detailed historic repository is I can actually correlate the SQL statements that go against the order line table. And you can start to look at the where clause in those SQL statements. And you start to notice that the where clause is pretty similar between the different SQL statements. And I would suggest to you that in your reporting system, you'll find the same thing, because the business users, the business analysts, are going to want to do things like aggregate business activity over the last day, the last week, the last month, the last quarter, the last year. So you're going to see very similar where clause, order by, group by, And that means that there's going to be certain indexes that make sense for those SQL statements. And so Precise has a recommendation engine. You can see that in the top right-hand corner. And what we can do is actually get recommendations saying, hey, I'm running all of these SQL statements. What indexes would address them? Those indexes are presented to you, and you can actually see the DDL. Now, Precise does not offer, Precise is read-only. It doesn't offer the ability to click a button and create the index. But that's easy enough to do outside of Precise. But here's the crucial thing, is Precise allows you to evaluate and model the changes. So there's this evaluate button in the lower left-hand corner of the screen. And what that does is it shows the SQL statements in the before and after. So let's look at these SQL statements. You see this column here that says in MS SQL, and it says 1 hour, 4 minutes. So that top SQL statement executes or consumes about 64 minutes worth of resources, and its projected improvement is 98%. So these changes are going to save an hour's worth of processing. The next SQL statement is 27 minutes, and you basically save a third. So that's about 10 minutes of processing. Summed together, you're actually going to save hours and hours worth of processing by these proposed changes. And so being able to know this up front, being able to model this, you can also use the what-if capability to kind of say, well, I don't want to make that index, or what happens if I change the order of the column? And so I can use this modeling capability to find out exactly what's going to go on. The other thing that's crucial is that when I make the change, I can actually measure for an individual SQL statement. You saw the SQL statement history in the previous example, and I can actually verify that I achieved the savings that were modeled. And so that feedback, completing the feedback loop is absolutely crucial. All right, here is the final example I was going to have for you. This is an SAP shop, and they'd gone for a major upgrade. They were doing some stuff with custom transactions, and basically an end user was unsatisfied with the performance. And so what we did is we were able to focus in on what that end user experienced. And you can see at the top of the list, see hows, and the response time is a little over 61 seconds. So this thing is taking a minute to execute. Now you can see we have a stacked bar graph that's geared towards SAP. In the right-hand side, it shows client time, viewing time. The blue is application time, and in the SAP environment, that's ABAP code, and then the database. And so the database, it could be Oracle, it could be SQL, it could be HANA. We basically were able to show that. Now, what we did with Precise is we focused for that transaction and that user what SQL statements were coming out. Once again, that context to connect the dots. Now, this top SQL statement, you can see it's circled. It executes in 2 milliseconds. You really can't blame the database if it's executing so quickly. The execution count is very high. They actually kind of were able to go back to ABAP Coder and say, hey, what's going on? And he actually found that the call in the database was put in the wrong place, was nested in the wrong place within the loop, made the change, and then we're able to measure after. So you can actually see what the performance is after, not only at the SQL statement level, but also at the custom code level. And so they could live with a 4.5-second execution time. And so these are just a couple of examples of how Precise might be leveraged, you might leverage it. And just as a quick recap, Precise shows performance by location, by the end user ID. It provides context through the application stack, so you can drill in on root cause. And I think one of the big differentiators is to be able to know not just the SQL statement, but why a SQL statement is running slowly, and be able to identify the contention and basically offer more options for solving problems. So this is what Precise has to offer, and you can consume us, in a lightweight way, or if you have very deep, very challenging problems, we love to take those on as well.
All right. I have to say that was a lot of fantastic detail, Bill. Thank you for showing all those screenshots. And from my perspective, you really fulfilled what I was trying to explain at the top of the hour, which is, number one, you need to have the right tool. You must have a tool that allows you the amount of context required to identify all the elements in the equation, as someone said in a movie once. That was kind of funny. But let me go ahead and hand it over to Dez, because I bet he's got some questions for you. And I want to push one more of these slides just for visual candy, if you will. Actually, hold on, let me take this back. But Dez, I'm sure you've got some questions. Take it away.
Yeah, I do. Wow. So this tool's come a long way since I originally knew it, and I wasn't aware you'd actually gotten quite so deep in the stack now. That's just quite mind-boggling. Just really quickly, a couple of things. The deployment model, can you just really quickly in a minute or two just outline the traditional or typical deployment model? You mentioned it's available as a virtual machine. It can be run in the cloud. And I guess one of the questions that will probably come up, and I think there was a couple of questions came through in the Q&A section there, just to recap them in summary. For the normal deployment model and the type of access that's required, you know, is it traditionally deployed on-premise or hosted or in the cloud? What are the types of deployment models that you're normally seeing? And what type of access is required to kind of get that to work? You know, does it have, do we have to change things at the security level around network access and so forth? Or can this just behave as an end user?
Yeah, so currently the majority of installations are on-prem. More and more people are putting components of the application stack into the cloud, and so we can handle that as well. The deployment, we don't need a server to run on. It's going to meet certain specifications. We need to have a database to store the historic repository. So meeting those prerequisites is kind of the first step. The next thing is that we definitely need to have some knowledge of the application itself, and the installation is wizard-driven and basically fill in the blanks. Because of the depth of information we're getting, you know, from OS process level to, you know, the code that's executing, we do need to have some privileges. We have a secure data model, or security model, I mean to say, because the agents run under credentials that are totally separate from people who are using the metadata about the transactions, et cetera. Precise does communicate via TCP over IP, and so we require certain ports to be open. You know, just as a quick example, like the default port is 2702. I mean, that type of detailed stuff is something, if people are interested in, we could get into in more detail. But typically, we're very quick time to value. If somebody is facing a big problem, we can often, you know, get the thing installed and you know, shine a bright light on a situation in a matter of hours.
Yeah, I definitely got that sense. So in the deployment model, you talked about a very large scale and up to 500 instances, and then they could be federated. At the very entry level, what does it look like if somebody wants to, because I know IDERA is very big on giving access to free trials, free demos, and I remember seeing on the website almost everything can sort of be played with. For folk on here, and I think that I missed it earlier on, but I think there was a question that came up around what does a typical site look like, and how do people get access to this and start to play with it and get that type of experience where they can see whether they've got a way to address some performance issues. Can they download an OVF and spin it up on their hypervisor, VMware Hyper-V or laptop, or do they need a dedicated machine to run it on? You outlined the architecture before, but just very briefly in a minute or two, what does that look like for the entry-level deployment just to do a proof of concept, for example?
Yeah, so our model is a little bit different than the IDERA tools. We kind of fit more into the Embarcadero scenario where you would want to contact one of our sales reps. We would want to just, you know, discuss with you, you know, what are the challenges, and then I typically would, me or one of the SEs would be assigned, and we basically work through the installation with somebody. Typically, you would not run Precise on, you know, your laptop. You would want to have a VM or a server within the data center where the application lives to do the data collections. But we would help you through every step of that. If anybody's interested in pursuing that, definitely want to contact IDERA.
So one of the other things that struck me was that, I mean, a lot of what we've covered today is around reacting to performance issues. But it seemed to me that, and on live environments as people are using them. So as your first slide showed, somebody picks up the phone and says, "Application's running slow, help." But it struck me that during pre-release of applications or upgrades or new patches and fixes, you could go through a bunch of capacity planning and stress testing and have precise looking at the entire environment and actually find issues before you even put end users on the environment. Is that a use case that you've seen before, or are people sort of doing that as well, or is that not a typical use case?
Well, absolutely. We would want to use Precise throughout the application development lifecycle or the upgrade lifecycle as well. Precise offers a scalability view that will show the number of executions overlaid with the response time. Obviously, if both the number of executions and the response time grow together, you're not scaling, and you need to do something. That type of thing has helped immensely. I think it's a little less true now, but when people started putting production applications onto VMware, they were a little bit hesitant, and it was like, at the first thing, it'd be like, oh, we need to move this to physical. And what we can actually do is show what the resource consumption is so you can make the application more efficient. So at every step of the application lifecycle, you definitely want to use Precise. But I would have to say that production is really where performance matters the most, and Precise is geared towards 24/7 production monitoring. And so you really don't want to, run your production applications with no visibility.
Absolutely. So one other quick question just on that space. So, I mean, dev test integration, UAT, and so forth, I mean, it's great to have this tool, and I imagine app developers would absolutely love to have access to this through the life cycle, the software development life cycle. With the more complex architectures we're seeing now, so we've moved from dedicated service to virtualization. From virtualization, we're moving now to sort of, adoption of sort of outsourced to cloud hosting, and we're also seeing a transition to containerization. Have you seen many people deploy this in multiple sort of regions or zones? So someone might have, and in Australia we have a very big issue around privacy, and I know in Europe it's the same thing. I think it's becoming more of a case in the US where data that is able to identify me personally often needs to be in a more secure environment to the actual application layer, to the web layer, and so we have these deployments now where people might keep their database and their application stuff internally, but they can put their web layer and their delivery and caching and so forth out in a cloud provider such as Azure or Amazon Web Services and soft layer. How does that work with your normal deployment? Is that a case that you just got another set of collectors in the other region and that just aggregates them, or what does that look like in the Precise world in today's sort of bimodal approach of running IT of old legacy stuff in one place and you goodness sometimes in the cloud?
Yeah, so we support a mixed environment. One thing to consider is that there's different contracts with the cloud providers. Some of them will not allow any kind of agent or any kind of outside monitoring within the cloud. In order to install and monitor with Precise, you need to have a type of contract that allows that type of access. So there are definitely some restrictions that sometimes we have to work through, and so those are important kind of criteria to consider when you're, I guess, first signing those contracts, and then or if you need to deploy Precise.
Yeah, I've seen a number of instances where even with traditional database environment, if you're procuring that as platform as a service, particularly with the likes of Azure, if you're procuring the likes of HD Insights or SQL as a service as a platform, your usual tools can only dive so deep because they're not really that keen for you to look at what's under the hood, and so you kind of end up with a certain level of depth that you can monitor to, and all of a sudden you just can't see behind the magic curtain. It's self-service a thing. Is this traditionally something that would run inside a network operations center where the technical team, the folk under the CIO would only get access to, or is this also something that you can provide a level of access to end users? So maybe not necessarily the reception desk and traditional HR and finance people, but more savvy users who are doing, like, for example, data scientists, actuaries, statisticians, people who are doing really heavy workloads. Is it the case that they can get access to some sort of self-service access to see what's happening when they run these heavy queries and where the pain's coming about, so they can start to tune how their workload runs?
Yeah, so there's pretty good security within Precise, so you can set up users have different levels of access. At a very basic level, just the dashboard provides oversight, and then within the if somebody did want to go into the expert GUI, you can kind of restrict what they're able to see and what they're able to do, and kind of circling back to your previous question, in healthcare, you have all the HIPAA laws, and so there are definitely some considerations, and there's actually some deployment options so that we can work within those environments. One thing to consider, with the data that you've seen in this presentation is it's all metadata about performance, not the content of the tables. It's, and so it's really, it's not going to get into like kind of those types of privacy concerns.
Yeah. I did like that. I had a eureka moment about your fourth or fifth slide of the screen snaps, and I realized you're just pulling performance data, well, not just, but you're pulling performance data, you're pulling stuff, as you said, metadata out of the various levels of the stack. You're not actually looking at the content, and I think this is an interesting thing because it's one of those tools where you could either deploy it for a short term and look at what's happening in the environment, but not necessarily have to have, well, you don't have to have access to the data itself. You can even look down the way that queries are being run. The last thing, I guess, just quickly, and then I'll hand back to Eric, see if he's got a question, and get Rebecca to wrap up. You mentioned before that the overhead is nominal. Is it the case that it's even a noticeable overhead from the monitoring side of things and just watching the background, or is it such a negligible amount of overhead that it's just not worth considering?
Yeah, so I think on the database tier, each technology is a little bit different. On the database tier, Precise is pretty well known to be the lowest overhead. On the middle tier, there is, there's kind of a balancing act. It's not just Precise; it applies to everybody in terms of visibility and overhead. And so one of the things is we offer a number of sophisticated tools to control what the overhead is, and so we are designed for production, and it is definitely useful even if there's many problems in the bud during development in QA, but there's nothing like knowing what's happening in production.
Yeah, that's all good
stuff.
Yeah,
indeed.
Yeah,
so Eric, across to you. Have you got any funny questions?
Yeah, I would just say that I thought you did a great job of pointing out that context really is the key, and it's almost like as we move towards this era of the Internet of Things, you want everything instrumented. And I think the standard now in manufacturing is to do that, which is good news, right? Because you want to be able to pull information from all these different environments and stitch it all together. And I guess I'll just throw it over to you for some final comments, Bill. That's what you guys are focused on, is providing a visual interface through which some analysts, and IT analysts essentially, can monitor and analyze what's happening in this complex environment and then figure out what to change. Because it's not just a tool. You must have the tool, but you need that person who's going to dig into that detail and find the answers, right?
Yeah, so I kind of see it as boiling up to the top and prioritizing where is the most buyback. If it turns out that it's a different situation, because not every problem is in the database. If the database is, things are executing in a tenth of a second, but on the application tier, things are taking 3 seconds, that's where the most buyback is. And so kind of being able to isolate the problem tier and then what's happening within the tier to really focus in on where the buyback is, that really accelerates the resolution and the optimization of the application. And it's so much faster and so much better and so much more fun than people gathered into a conference room going, well, it's not me, it must be somewhere else.
That's right. I saw a great meme the other day that said something like, be informed, not just opinionated. And that's what you're talking about. You walk into a meeting, you have the information, you can point to the data. That's the key, and we're getting there, thank goodness. Okay, folks, we're going to go ahead and wrap up, but we do archive all these webcasts for later viewing. Feel free to check it out anytime. We list all of our webcasts now, the Hot Tech series and the Briefing Room series at techopedia.com, so hop online and check those folks out. With that, we're going to bid you farewell. Thanks for your time today, Bill. Thanks for you and all your hard work, Des, and we'll talk to you next time, folks. Take care. Bye-bye.